Robotics Introduction. Actuator. A component of a machine that is responsible for moving or controlling a mechanism or system. Algorithm. A step-by-step procedure or formula for solving a problem. Autonomous. Capable of operating without human intervention. Calibration. The process of adjusting and setting up equipment to ensure accurate measurements. Component. A part or element of a larger system. Controller. A device or software that directs the operation of a machine or system. Debugger. A tool or software used to test and debug code. Deployment. The process of setting up and launching a system or application. Diagnostics, tools or processes used to identify and troubleshoot problems. Encoder. A sensor that converts motion into a signal that can be read by a computer. Firmware, permanent software programmed into a read-only memory of a hardware device. Interface, a point of interaction between two systems or components. Integration, the process of combining different systems or components to work together. Kinematics, the study of motion without considering the forces that cause it. Manipulator, a robotic arm or other mechanism used to interact with the environment. Modeling, creating a representation of a system or component for analysis or design. Navigation, the process of determining and controlling the movement of a robot. Payload, the part of the robot that performs the task or carries the load. Protocol, a set of rules or standards for communication between devices. Robot, a programmable machine capable of carrying out a series of actions autonomously or semi-autonomously. Sensor, a device that detects and responds to physical stimuli, such as light, heat, or motion. Simulation, the imitation of the operation of a real-world process or system. Software, programs and operating information used by a computer or robot. Trajectory, the path that a robot or object follows as it moves through space. User interface, the means by which a user interacts with a computer or robot. Let me know if there's a specific area or detail you need more information about. Certainly. Futuristic tech terms that are likely to shape the future of technology across various fields. Augmented reality, AR, technology that overlays digital information onto the real world, enhancing the user's perception of reality. Blockchain, a decentralized digital ledger used to record transactions across many computers securely. Quantum computing, a type of computing that uses quantum bits, qubits, to perform complex calculations much faster than classical computers. Artificial intelligence, AI, the simulation of human intelligence in machines designed to think and learn. Machine learning, ML, a subset of AI that involves training algorithms to recognize patterns and make decisions based on data. Neural networks, AI systems inspired by the human brain that can learn and adapt through interconnected nodes. Fifth generation technology, 5G, the fifth generation of mobile network technology offering faster speeds and more reliable internet connections. Internet of Things, IoT, the network of physical devices connected to the internet, enabling them to collect and share data. Wearable tech devices worn on the body that can track health metrics, provide notifications, and integrate with other technology. Self-driving cars, autonomous vehicles equipped with sensors and AI to navigate and drive without human input. Smart cities, urban areas that use digital technology to improve performance, well-being, and reduce costs and resource consumption. Biometrics authentication methods that use biological traits, such as fingerprints or facial recognition, to verify identity. Gene editing, technologies like CRISPR used to modify DNA sequences for research, treatment, or enhancement. Virtual reality, VR, immersive digital environments that simulate a user's presence in a computer-generated world. Nanotechnology, engineering, and manipulation of materials at the atomic or molecular scale to create new devices and materials. Drones, unmanned aerial vehicles used for a variety of applications, including delivery, surveillance, and data collection. Augmented reality glasses, wearable devices that overlay digital information on the real world, similar to AR but through glasses. Robotic process automation, RPA, the use of robots or software to automate repetitive tasks in business processes. Synthetic biology, the design and construction of new biological parts, devices, and systems, or redesigning existing biological systems. Three-dimensional printing, 3D printing, the process of creating three-dimensional objects from a digital file by adding material layer by layer. Edge computing, computing that occurs at or near the data source, reducing latency and improving speed and efficiency. Smart contracts, self-executing contracts with the terms of the agreement directly written into code, often used on blockchain platforms. Holography, technology that creates three-dimensional images through the interference of light beams from a laser or another coherent light source. Digital twins, virtual replicas of physical entities used to simulate, analyze, and optimize real-world systems or processes. Exoskeletons, wearable devices that enhance human capabilities or assist with movement and strength, often used in rehabilitation or industrial settings. These terms encompass a broad range of emerging technologies that are set to revolutionize various aspects of our lives and industries in the near future. Japan is renowned for its advanced technology and innovation across multiple fields. Here's a list of some notable technology areas and terms related to Japan's technological landscape. Robotics. Japan is a global leader in robotics, with companies like Honda, Asimo Robot, SoftBank, Pepper Robot, and Fanuc creating advanced robots for various applications, including industrial automation and personal assistance. Artificial intelligence, AI. Japanese companies and research institutions are at the forefront of AI development, applying it in fields such as healthcare, finance, and autonomous vehicles. Notable institutions include AIST, National Institute of Advanced Industrial Science and Technology. High-speed rail. Known for the Shinkansen or bullet train, Japan has pioneered high-speed rail technology, significantly reducing travel time and increasing efficiency. Consumer electronics. Japan is home to major electronics companies like Sony, Panasonic, and Sharp, known for their innovations in imaging, entertainment, and home appliances. Semiconductors. Japanese companies like Intel Japan and Tokyo Electron are major players in the semiconductor industry, contributing to the development of microchips and electronic components. Precision machinery. Japan excels in high-precision machinery and manufacturing equipment, with companies like Makino and DMG Mori producing advanced tools and machines. Renewable energy. Japan is investing heavily in renewable energy technologies, including solar power, wind energy, and hydrogen fuel cells. Companies like Kyocera and Toyota are key players in this sector. Advanced materials. Japan is a leader in developing advanced materials such as carbon fiber, graphene, and smart materials used in various industries including aerospace and electronics. Smart cities. Japanese cities are incorporating advanced technologies to create smart cities with improved infrastructure, energy management, and quality of life. Fukuoka and Kashiwa-no-ha are examples of smart city initiatives. Bioengineering. Japan is known for its advancements in biotechnology and medical devices, with innovations in areas like genetic research, prosthetics, and robot-assisted surgery. Virtual reality, VR. Japanese companies like Sony are pioneers in VR technology, with products like the PlayStation VR enhancing gaming and entertainment experiences. Telecommunications Japan is at the cutting edge of fifth-generation technology, 5G, with companies like NTT Docomo and SoftBank leading the rollout of next-generation mobile networks. Holography Japan has made significant strides in holographic displays and holographic technology, with applications in entertainment, advertising, and communication. Gaming. Japan is a major hub for video game development, with influential companies like Nintendo, Square Enix, and Capcom leading in game design and technology. Nanotechnology. Japanese researchers and companies are advancing the field of nanotechnology, exploring applications in medicine, electronics, and materials science. Autonomous vehicles. Japan is actively developing autonomous driving technologies with companies like Toyota and Honda investing in self-driving car research and development. Smart home technology. Japanese companies are innovating in smart home devices, integrating AI and IoT to create connected and automated living environments. Space technology. Japan's JAXA, Japan Aerospace Exploration Agency, is involved in space exploration, satellite development, and space missions. These areas reflect Japan's commitment to technological advancement and its role as a global leader in various tech sectors. Robo history. The history of robotics is a fascinating journey that spans centuries, evolving from early mechanical devices to today's advanced robots. Here's an overview of key milestones in the history of robotics. Ancient and early mechanical devices. Ancient Greece and Rome. Hero of Alexandria from the 1st century AD created early mechanical devices, including an automated puppet and a vending machine. The Antikythera mechanism, circa 100 BC, was an ancient Greek analog computer used to predict astronomical positions and eclipses. Middle Ages. During the Islamic Golden Age, scholars like Ibn al-Haytham, also known as Alhazen, made significant contributions to mechanical engineering and optics, laying the groundwork for future robotics. Renaissance to 19th century. In the 16th to 18th centuries, Leonardo da Vinci, in the late 15th century, designed a mechanical knight, one of the earliest concepts of a humanoid robot. Jacques de Vaucanson, in the 18th century, created a series of automata, including a mechanical duck that could eat and digest. In the 19th century, Georges Devol, in the early 20th century, invented the first programmable robotic arm, known as the Unimate, which became the basis for modern industrial robots. 20th century developments. In the 1920s, Karel Capek's play Ruhr, Rossum's Universal Robots from 1920 popularized the term robot, depicting artificial beings created to serve humans. In the 1940s, Isaac Asimov introduced the 3 laws of robotics in his science fiction writings, influencing both the philosophy and ethical considerations of robotics. The development of early robots like the Unimate marked the beginning of robots being used in manufacturing. In the 1950s, George Devil and Joseph Engelberger created the first industrial robot, the Unimate, which was installed in a General Motors factory in 1961. In the 1960s, Shaky the Robot, developed by the Stanford Research Institute in 1966, was the first robot to combine perception, action, and reasoning. Modern robotics. In the 1970s, the use of robots in manufacturing increased significantly, with companies like Fanuc and KUKA leading in automation. In the 1980s, advances in robotics led to the development of sophisticated prosthetic limbs and exoskeletons. In the 1990s, Honda introduced Asimo in 2000, a humanoid robot designed to assist with various tasks and interact with people. In the 2000s, iRobot introduced the Roomba in 2002, a robotic vacuum cleaner that became a popular consumer product. Boston Dynamics became known for developing advanced robots like Big Dog, which demonstrated impressive mobility and stability. In the 2010s, the integration of AI with robotics led to the development of robots capable of complex tasks, including autonomous vehicles and advanced service robots. Hanson Robotics unveiled Sophia in 2016, a humanoid robot known for its advanced conversational abilities and human-like appearance. In the 2020s, the rise of collaborative robots, or cobots, designed to work alongside humans, increased their use in various industries. Robots like Spot by Boston Dynamics and Pepper by SoftBank continued to advance in fields like healthcare, customer service, and exploration. Future prospects. The future of robotics is likely to see continued advancements in artificial intelligence, enabling robots to perform more complex tasks and interact more naturally with humans. Autonomous systems will enhance capabilities in autonomous vehicles, drones, and space exploration. Human-robot interaction will improve interfaces and collaboration between humans and robots. Ethics and regulation will address ethical concerns and create regulations for the use of advanced robots in society. This history reflects the remarkable progress in robotics from simple mechanical devices to sophisticated systems with broad applications. 18th century Robo innovative history. The 18th century was a period of significant innovation in mechanical devices and automata, laying the groundwork for future robotics. While the term robot was not yet coined, inventors and engineers of the time created remarkable devices that demonstrated early concepts of automation. Here are some notable innovations and contributions from the 18th century. Key innovations and figures. Jacques de Vaucanson, who lived from 1709 to 1782, created the digesting duck in 1739. This mechanical duck could eat grain, digest it, and defecate in a manner that impressed many. This automaton was an early example of a machine mimicking biological processes. Another of Vaucanson's creations was the flute player from 1738, a mechanical figure capable of playing the flute with realistic movements and sound production. In 1749, Vaucanson also created the tambourine player, an automaton that could play the tambourine, showcasing his skill in creating lifelike music-playing machines. Gottfried Wilhelm Leibniz, although his work mostly predates the 18th century, made contributions in mathematics and mechanical calculators that influenced 18th century developments. His ideas on mechanical calculation and logic laid the groundwork for later innovations in automata and robotics. Jean-Baptiste Simon, who lived from 1740 to 1799, designed the mechanical swan, an automaton that could mimic the movements of a swan, showcasing the intricate craftsmanship and mechanical ingenuity of the period. John Joseph Merlin, who lived from 1735 to 1803, was known for his work with mechanical automata, including a mechanical figure that could mimic human movements. He was also an inventor of early versions of roller skates and other mechanical devices. William Stanley Jevons, although he worked in the 19th century, built upon the concepts of earlier automaton designs. His work in mechanical engineering and logic was influenced by the automata of the 18th century. Impact and legacy. The 18th century saw a fascination with mechanical automata, which were often used for entertainment and demonstration purposes. These devices demonstrated the potential for machines to imitate human and animal behaviors. The precision and complexity of 18th century automata highlighted the advancements in mechanical engineering and craftsmanship, influencing future developments in robotics and automation. The innovations of the 18th century set the stage for later developments in robotics by showcasing the possibilities of mechanical motion and control, leading to more sophisticated robots and automated systems in the 19th and 20th centuries. Overall, while the concept of robots as we understand them today did not exist in the 18th century, the period was marked by significant mechanical innovations that laid the groundwork for the field of robotics. 20th century history. The 20th century was a transformative period for robotics, characterized by rapid advancements in technology and the establishment of foundational concepts that shaped modern robotics. Here's a detailed look at key milestones and developments in robotics throughout the 20th century. Early 20th century developments. In the 1920s, Karel Capek's play Roer, Rossum's Universal Robots, from 1920, introduced the term robot and explored themes of artificial beings created for labor. This work had a significant influence on the cultural and scientific understanding of robots. In the 1930s and 1940s, early 20th century advancements in electronics and mechanics led to the development of automated devices and systems in various industries. Mid-20th century innovations. In the 1950s, Isaac Asimov's 3 Laws of Robotics from 1942 provided a framework for thinking about the ethical and functional aspects of robots. George Devil and Joseph Engelberger developed the first programmable robotic arm, the Unimate, in the early 1950s. The Unimate was designed for industrial tasks and was installed in a General Motors factory in 1961, marking a significant milestone in industrial automation. In the 1960s, Shaky the Robot, developed by the Stanford Research Institute in 1966, was the first robot to combine perception, reasoning, and action. It could navigate its environment, make decisions, and execute tasks based on its programming and sensory input. The Defense Advanced Research Projects Agency, or DARPA, was established in 1960 to fund and advance cutting-edge research, including robotics. DARPA's support led to significant innovations in robotics and autonomous systems. Late 20th century advancements. In the 1970s, the use of robots in manufacturing became more widespread. Companies like Fanuc and KUKA emerged as leaders in industrial robotics, providing solutions for automation in various industries. Honda began researching humanoid robots in the 1970s, eventually leading to the development of robots like Asimo in the 21st century. In the 1980s, advances in robotics led to the development of sophisticated prosthetic limbs and exoskeletons, improving the quality of life for individuals with disabilities. Researchers began to integrate artificial intelligence and machine learning algorithms with robotics, enabling robots to perform more complex tasks and learn from their environment. In the 1990s, iRobot introduced the Roomba in 2002, a robotic vacuum cleaner that became a popular consumer product. This marked a significant step in the commercialization of robotics for home use. The 1990s also saw increased interest in robotics research, leading to innovations in autonomous vehicles, robotic surgery, and advanced sensors. Impact and legacy. The development of industrial robots revolutionized manufacturing processes, increasing efficiency and precision while reducing the need for human labor in hazardous environments. The 20th century's advancements in robotics and AI prompted discussions about the ethical implications of robots in society, including issues of autonomy, safety, and job displacement. The innovations and research of the 20th century laid the groundwork for the sophisticated robotics and AI technologies of the 21st century, influencing fields such as autonomous vehicles, healthcare robotics, and service robots. The 20th century was marked by significant progress in robotics, from early conceptual ideas to practical industrial applications. These advancements set the stage for the rapid evolution of robotics technology in the 21st century. Indian Robo history. The history of robotics in India reflects a journey from early experimental work to significant achievements in both research and practical applications. Here's an overview of key milestones and developments in Indian robotics history, early beginnings and developments. In the 1960s to 1980s, the roots of robotics in India can be traced back to the 1960s and 1970s, with initial research focusing on automation and control systems. Institutions like the Indian Institute of Technology, or IIT, and Indian Institute of Science, or IISc, began exploring robotics and related fields. Dr. P.K. Narasimha, a notable figure in robotics, contributed to early research in robotics and control systems in India during the 1980s. In the 1990s, Indian institutions like IITs, IISc, and other engineering colleges began to establish dedicated robotics research labs. Research focused on both industrial robotics and academic exploration. Indian researchers started developing robots for various applications, including industrial automation, healthcare, and service industries. The 1990s marked a period of growth and institutional involvement in robotics research and development in India. The The history of robotics in India showcases the country's journey from initial experiments to significant achievements in research and practical applications. From the early beginnings in the 1960s to the growth and institutional involvement in the 1990s, Indian robotics has made remarkable progress, contributing to the global advancements